Got some dumbass shit I gotta do here. Because C doesn't have a standard template library like C++ does. I have to build my own data structures. Manage my own shit. One of the things that I was utilizing in the previous C++ version of the game was unordered maps in STL. Very useful. You can declare one to be of one data type mapping to another data type, and you can get pretty complicated with the templating schema. We don't have templates in C. We're gonna have to raw dog our own data structures. One of the things that I need to do is, oh, hello. Thank you. One of the things that I need to do is build a hash map. And we need to build a hash map, actually 2 of them. We actually have to have a hash map for every data type combination that we want to actually handle. But in the very beginning, we're only going to work with entity ID to entity, right? So the other day I created an entity type, super basic. All it has is an entity ID and a name. Super basic, right? Eventually this is going to grow and have a lot more on it, but in the very beginning we're just going to be working with this, and we're going to be mapping entity ID, which is already a property on it, keep in mind, but we want really quick lookup of objects. That's why you want a hash table. That's why you want maps. It's a very powerful data structure in this way. It's better than a vector. It's better than a set. It's better than a queue. It's better than linked lists. But funny thing, we're actually going to have to implement a linked list in order to handle a certain edge case of hash tables. Now, edge cases, what happens when 2 keys collide? So I'm going to try to take y'all from the ground up through the implementation of a hash table and a linked list at the same time, specifically for game development purposes. Because as I said, we're doing this in C and we don't have our own data structures, so we have to create everything from scratch. I could use some external library, and I've done a little research, but like, at the end of the day, this is good practice for me in a lot of different ways. It's good practice in going over things that I learned in school. It's good practice in actually teaching people how something works and how to actually go about implementing it. And I'm going to try and make this fun somehow. Okay, so here's all our .h files. Here's all our .c files. As you can see, we have more .h. And that's because some of these are just simply type definitions, right? Like it's a declaration of a struct. And a struct might be used elsewhere. Not every struct necessarily requires fancy constructors and object files and stuff like that. It's essentially what a header file is something that gets like included. And by included, I mean during the compilation phase, contents of it are essentially copied over during the pre-process step, right? So at the end, when a single object gets compiled, it's like the amalgamation of whatever source you input and then a list of objects that follows that might be used by the resulting object itself. We're going to declare a, let's see, all right, so we have a new branch. So I'm declaring two structs to start with. Each element in the actual hash table is going to be a hash table entity node. It's essentially a wrapper around the entity and the entity ID. So remember that each entity has an entity ID attached to it already. So here's our node, right? Composed of a key, a value, and a next. Now, I don't think we necessarily want to store the value on the stack, so this should probably also be a pointer. Because all of the actual entity objects are going to be stored in the table, right? So Copilot's generated these function declarations for me. A lot of basic operations that are used in a hash table. Create, destroy, insert, search, delete, print. Okay, so that's not quite right. Yeah, it's entity entry. Oh, no, no, no. There we go. Incomplete definition. Oh, is it because we never did type? Oh, shit. Oh, I see. That's why. There we go. All right, so we've got the create, we've got the destroy. I get what this does now. So this actually, like whenever we insert the nodes, if the node conflicts with the previous node, the new node that we're inserting will become the front of the whole list of nodes, which is probably okay. What's up, Android? What's up? Yeah, for those who are unaware, I have a physical deformity with my right hand. I'm unable to type using all 10 fingers. I'm thankful that I can type at all with 2 hands. And so one of the reasons I use Copilot is for autocomplete purposes. Don't trust everything that Copilot throws you. I've been able to break Copilot many times before, but when you organize things in a certain way and you read over its output, it can be a very helpful tool in actually getting things done faster. Not to mention what they call boilerplate is a great example. And what we're doing largely here is boilerplate, not to mention code that's just been written a million times before. But anyone who doesn't know how to do this should definitely go through the motions beforehand. For me, this is kind of an exercise in walking through something I've already done a million times before. So let's see. Hash table entity search. So from here, it grabs the index that we calculate for the given key, which is just an integer. Next, it's going to create a new node pointer and assign it to the index that we find, or the item at that index, the head. And at this point now, it's going to have to step through each item potentially in that list, because of course, as I explained before, there could be hash collisions. So while node not equal to null, if node pointing to key is equal to the key, then we go ahead and return the value stored at that location. Otherwise, we move on to the next node in the sequence. This is basic linked list walkthrough. And if we don't find the value, we return null. A way to reorganize this code, like for instance, let's turn Copilot off for a moment. Oh yeah, it's very comfortable using them, especially since I figured out how to use left-handed mode. So like, very nice. Like, to me, being able to navigate freely through the terminal is so important, and it's been so liberating, given my circumstances. There's no greater place I would rather write code than right here. Perhaps there is, and I just haven't imagined it yet, right? But this is pretty fucking good. It is NeoVim. It is NeoVim with a handful of custom plugins, and let's see. Okay, let me continue here. One of the things that we can do to like kind of just like, it doesn't matter that much, but one of the things that I remember having a discussion about a long time ago was writing functions with single return statements versus having returns within the deepest part of a branch, for instance. Like this return statement is here, but one thing that we're able to do is declare a new node for our result and set that to null by default. Then, instead of doing this, we can do this. Result equals this. Or wait, sorry. We can do this. Oh, it has to be an entity type, right? So we can do this and then break. To start with, I'm just using simple hashing, but I was researching hash functions last night, and there's a couple interesting ones that might be worth experimenting with. But since we're using integers, it's not like we need a hyper complicated hash function. I think the name of the one I was looking at was like mean squared or something like that, where you end up with this different range. Like there's a handful of different integer hash functions that can be used. I'm not going to roll my own. It would be interesting to try and do so, but of course. Let's see. All right, let's get the next one rolling. Delete. It's going to use a similar process to search. I'm going to go and turn Copilot back on. So we go ahead and grab the index, and then it does the same process where it jumps to that point in the table. If that location is null, then we return. If the node at that location is already the key, then we set the pointer at that index to point to the next item in the list, so that we essentially detach the node. We free it, and then we return from the function. Otherwise, we're going to have to step through the list, find the node, delink it from the list, free it, and then return. So delinking nodes from a linked list that's like a single linked list is essentially like this. And see, as it is, like fucking Copilot got this shit wrong already. This is node type. This is node type. So as you're stepping through the list, if you find the item that actually matches and you want to remove it, you first create a pointer to the next node in the list, right? And then you can take the pointer to the original node and set its next up to the next. So they're actually comparing based off of next here, but you could do this with like, you know, you could write this a number of different ways, but essentially it's the same meaning. At this point, it's delinked, and if it even existed, we might want to consider returning a true or false success value. And in fact, we might even consider searching the table beforehand before we even attempt to delink, right? Because the search would come back with a pointer to the actual entity itself. And that can be used as like a true or false value. But I think this is probably good enough for right now. I wouldn't necessarily want to return. We could break instead. Now we're getting into the realm of just eliminating these early return statements. So if we return a node and node is exactly equal to the key, then we go ahead and delink the node and free it. Otherwise, we step through the list of nodes on that location, check to see if any of them correspond with our key, and if they do, delink the node, free it, break out of the loop, and we're good there. Now, I don't really think we care about printing necessarily right now, so hash table entity ID entity. There we go. That's all we have to do, attach a new object to our whole setup here. Makes things very easy. Oh wait. There we go. Alright, so there's my auto-compiling setup. So now anytime I make a change to a file that's listed in the .c files, it'll just remake that object, remake the libgame object, and then reload it once it's actually running. So now they're not going to be anything that we can like really demo, but I can show you all the state of the game at the moment, like how it looks, using the new assets that we've acquired, or rather the one asset that I have implemented. But part of why I'm doing the map stuff right now, the hash table stuff, is I want to be able to start adding other objects very easily. And right now, this guy is just sitting on here on his own, because once the hash tables are done, he's going to go into a hash table. He's going to go into two hash tables, actually. His entity data will go into one, and his sprite data will go into another. So as an example of like my ability to change this shit on the fly, right? Not that y'all haven't seen me do this before. So like in load texture, and actually not load texture, it's actually in raw game placing. So check this out. And now he's red. And we can make him whatever color we want. Which is really kind of a small thing, but it's like kind of fun, not gonna lie. So this is his normal color when he's all white, but you can still see a little bit of the detail with the shading. He looks pretty good at any zoom level, but very clearly the game at this zoom is going to be harder to navigate, right? But like at the same time, one of the things I'm going for is like a really big overworld. Potentially big. I want to have both big and small like floors, you know what I mean? Like each zone or each level or what, however you want to think about it, like dungeon floor section, like, you know, we're gonna have both big and small, and it's gonna appeal for different styles of gameplay. What is going to be the core gameplay loop? Okay, so with you've played NetHack, I hope, or some form of turn-based dungeon crawling. So one of the things I did off stream the other day was I got this smooth movement going, which is something I didn't have previously. Oh yeah, so if you Dragon Quest is like definitely like partly in my background of inspiration, right? Like while I was in college, I beat the original Dragon Quest in Japanese for the original Famicom. I got an emulator of it, right? And I forced myself to go through it as a practice of Japanese and also just gaming history. And it took me about like 30 hours, I think, and it was fun. It was like a really solid representation of the so Dragon Quest is great for a lot of reasons, but one of the things that, in my opinion, kind of marred the Japanese RPG genre for a long time was the separation of like the overworld or like the navigation of dungeons and stuff from the actual battles. The battles had a completely separate scene that it would shift to, and it would present you with a linear list of options that you would select to, you know, like cast fireball on target or attack target or use item on self. And this is very different from something like NetHack, right? Or one of the, if you're familiar, Android, with the, you want to see my face? Hold on. What's up? Like, if y'all are familiar with the Pokemon Mystery Dungeon series, or if you're familiar with Shiren the Wanderer, or Darkest Dungeon, or even older than this, like Eye of the Beholder on the original Super Nintendo or its PC equivalent, or the original, like I never played the original Baldur's Gates, right? But I think those were actually real-time games, weren't they? Baldur's Gate is in the same target area, like Diablo as well, but Diablo is also like a real-time, right? Great games in their own regard, definitely inspiration, but what I'm going for is turn-based, because I used to play Dungeons and Dragons in my dad's garage growing up with my friends, like in middle school and high school. Every weekend for about like 2 years, we would gather for a Friday night and Saturday. In the best case, we actually had 2 sessions back to back, one night after the other, and they would last like 90 minutes to like 4 or 5 hours long each, right? Then during the daytime, like we would, you know, fuck around and play video games, Magic the Gathering, shit like that. And Magic's nice because it's turn-based. D&D's nice because it's turn-based. It's not to diss on like real-time games, but a lot of the ways that I think about game design are from a very quantum or like discrete, you know, like discrete versus continuous, right? Like if real time is continuous, then I think about a lot of the games that I want to make in terms of discrete like units of time, right? player has as much time or possibly a limited amount of time to make decisions before the game state updates and the nature of the player's decisions have to change. Like, so we got this data structure now, right? MMOs are interesting, but I also feel like that there is a strong, like, I feel like there's a future where MUDs could have a breakout, like, success in the mainstream, but nobody's ever brought that style of gameplay to a wide audience yet, right? Like, I think that's because a lot of people have not married the concepts together of like modern mobile gaming with interfacing with a large multi-user system like that. I've wanted to look into like how I might go about implementing something like that myself, because one of the things I think about is like if you have 2 players in one dungeon and a player makes their move, and then like every turn there's a turn order, right? And if you have a lot of other monsters on the floor with you, and if you're trying to simulate the whole dungeon, that's another design factor I have to think about. But if you have like 2 players and a bunch of monsters on a floor, and you have a turn order generated for like turn 1, and monsters take their turn, then it's player 1's turn, and then other monsters take their turn, and then it's player 2's turn. When you have 2 players in the dungeon, and the worst thing about like a game of chess is that one player could take forever. They could take days to make their move. So is it appropriate to like set a time limit for people on how long before the next turn unfolds? Because I'm trying to create a balance between rapid fire gameplay potential and being able to allow the player to make those decisions thoughtfully. Because at a certain point, once you level up, once you acquire a certain amount of gear, once you traverse so far into the game, it's going to become very difficult. That's one of the goals. Just out of the nature of procedural generation and level progression, right? The number of decisions that you have to make and are able to make at that point skyrockets, and it like exponentiates, right? So you want to find a balance. And so like as I'm moving forward and I start adding things, I'm going to try and find a way to like keep things literally balanced. So in the very beginning, once we start like adding the ability to interact with other entities, we're gonna add initial equipment, simulate like initial combat, and see how far we have to tweak the numbers, because I plan on using like D&D mechanics for like the initial basis of doing combat. Like everything's gonna be dice based. So we need to get this. I'm done rambling. I want to get this a test of this hash map rolling, right? Like, so I don't have any unit tests. Oh, wait. we need to do a string copy. Wait, 100? No, it's like 128. This makes me think we might actually want a search by name function, right? But I don't see the immediate use case for it. Because there could be, like, for instance, multiple entities on the screen that have the same name. But the way that I'm designing the system, everything should have its all right. So there's our unit test. Now, interesting that it didn't find it didn't find our entities. Good thing I wrote this this test. So this probably messed it up, right? Like, oh yeah. We never returned results. There we go. Okay. That was interesting, the order that things got printed out there. There we go. Okay, so for some reason in NeoVim it decided to like weave or like separate out the search statements from the actual prints that follow them. At some point I should probably robustify my imprint stuff, but let's see. This would actually need to be part of the game state. Uh-oh. There we go. Okay. Yeah, see, that's like not very organized, right? All this stuff is going to go into a map pretty soon. So even if an object is not like immediately in the dungeon, but if we spawn it, it'll have an entity ID so that if it does get placed in a dungeon, or if it's like picked up in our inventory, we can reference the same sprite to draw it in either location. Do you think you'd use an LLM powered terminal? I think you could probably build something yourself to enhance your terminal if you really want to integrate like LLM capability stuff. As an example of this, I have this repo called ChatGPT tools. I can directly interface with ChatGPT from my terminal already. And if I wanted to build something really custom, I'm totally capable of doing that. I like interfacing it with it from the terminal rather than doing it from like the web. This integrates a lot more easily with being able to like save output to like a text file, or say hi to everyone on Twitch. I can't interact with Twitch directly. I'm here to help you with coding and technical questions. No, just say hi. Nice. But look, ChatGPT says hello everyone on Twitch. If you have any coding questions, feel free to ask. Enjoy your day. So like, I could actually write a chatbot for Twitch that allows y'all to directly ask it questions. You know, I could wire up. I've even considered using LLMs for design. You know, like finding a way to script out design decision capabilities. Like, you can get ChatGPT to generate JSON. So like, if you were to write a game or a program that accepted some JSON input, you could wire up ChatGPT to your application by getting ChatGPT to generate JSON using the syntax or keys and values that like you would expect. And I see like a lot of capability and possibility for that kind of thing. It would be sick to like run run LLM find all files starting with foo, and it runs it. Yeah, I would be very careful about allowing an LLM to run commands so much as just generate them. Like, let's do another example here. So, what command would I need to execute in bash to find all files under a given directory beginning with the letters TEX? To find all files under a given directory beginning with the letters TEX in bash, you can use the following command: find path to directory, type F, name, text star. Replace path to directory with the actual directory path where you want to search for the files. This command uses the find command to search for files, type F, with name starting with text. It even comes back with like a pretty good explanation of it. It's pretty fast. So like, I keep track of like the response time. So like over the course of a whole conversation, you can have stuff. Plus I save the chat logs. And you know, that way, like if you need to look something up that you've previously done, you can do so quickly. There's just like so many more benefits to doing it this way than like actually interfacing with the web app. Like, a lot of people bitch and complain about like certain aspects of this whole LLM situation, but like honestly, there is what I feel like a right way to do this. Over in libinit shared setup, shared setup, before we actually load our textures, or actually before we actually create, well, no, yeah, after we load textures, but before we create sprites, we're going to create a hash table. And okay, it's just taking a name. Right on. Appreciate that, Android. Thank you. Have some good dinner. I haven't eaten anything today yet. It's not called an add, it's called an insert. Too few arguments, what? So I'm assuming this works because it's not crashing, but if we wanted to be really sure, we should write a little check function that we can hit with our keyboard. We also are going to have our vector of entity IDs dropped in here too. Oh, this is all done on the stack. Okay. Might be okay. Probably take a break here in a little bit. So because it's on the stack, we don't have to worry about freeing at the very end. It's kind of nice. So I have to find a way to keep track of the hero entity ID. There we go. You can see it at the bottom. So we have officially integrated our first hash table. I have to piss, and I'm sure my dog has to go piss. So we're gonna do this.
Y'all don't even know that. 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 Y'all don't even know that.
Okay. I ordered some pizza. I'm fucking hungry. And we're just about done for today, but now that I have this actual map working, we need to take a look at how we're gonna go about adding this sprite group, right? Because this is just one sprite group, and we're gonna need a map specifically for entity ID to sprite group. Now let's take a look at sprite group because it's been a little while. It's very simple. We've got a double pointer to all of the sprites. We've got a move, a destination, a current, a capacity, and a size. Now remember, we wanted to separate out the entities from the sprites. So this is how we do it. So we've got the entities separated at the moment. And in this whole process, we're creating one sprite group just for the hero. Eventually, this is going to get wrapped up into a tidier function. But a lot of this code is going to be the same. All we're really doing is changing names. So like for instance here, we're change entity ID entity to entity ID sprite group. So of course, instead of entity type, it's going to be sprite group. Oops. Sprite group type. All right, so that one's done. Actually, I think we'll have to relist the entity stuff as well. Alright, so everything looks good so far. We've changed the names of everything pretty much in like only a handful of keystrokes. So for a given entity ID, we will now have a hash table entity ID sprite group as well. Over in the make file. Now there's our sprite group. And then we also have to add it here. Let's see. Okay, so yeah. Game state doesn't necessarily need that rule on it, because it waits for the very end for everything to link anyway. Alright, so there's our All right, so there's our sprite groups, right? So we've added our entity to the entity vector. Close shared. Oh, we never destroyed it. So we don't need to call destroy on our vector of entity IDs because it's on the stack. Now, the problem here is, or wait, no. It's still on the stack. And we still have to free the data. Now, we don't have a sprite group hash table yet. Now we do. And we push back our hero ID entity to our list of entity IDs. We insert that into our entities table, associating the hero entity with the ID that it was assigned. Now down here, we've finished creating the hero group, so we can actually add it. So pretty soon we'll be able to get rid of the reference to the hero group itself and start using the hero group as it's stored in the hash table. All these references to hero group, we're going to have to add a pointer to them so that this code still works. Now, here we're creating our sprite group locally now. But all the other places that we reference it, we're going to have to associate the pointer with the actual object in the table itself, right? So at this point, we've inserted it into the table. So sprite group type hero group equals the search for the item. If hero group all right, so next so this is how we actually get the hero group. Now we can make the assumption here without writing error checking code, but we want to be pretty good about this. Oh, it's sprite group type. Sprite group type like that. Okay, no errors, so that's good. Let's see. We're almost done here. If everything builds, runs, and does exactly what it used to, then and I'm able to successfully reload the state, then everything's a success, and we'll be ready next time to actually put some new objects in this game. We're probably gonna have to refactor a lot so that it's a lot easier to add new things, because this is a lot of code just to add like one dude. But as you can see, he has, for every single action that we have available, its own sprite. So everything from here to here is just slicing out those sprites from the texture. And then down here, we actually create the hero's sprite group by adding each one of those sprites to it. Then we set the destination and the current frame, and then we insert it into our sprite groups. Moment of truth. It compiles. It runs. And it still works. Now we actually don't really need the hero group stuff inside the debug panel anymore. I think my pizza's here. Let me go get that. got some pizza. And we've got this working, so let's commit everything before we forget. Build time's a little bit heftier, and we just broke 2,000 lines of code, but of course this is going to get cleaned up like heavily. Take a look at our changes for today. Two hash tables. Entity ID to entity and BID to sprite group. There's our merge, and we can delete the old. Wait, we still got a thing for asset loading. All right, now everything's cleaned up, and I'm gonna take a break. I forgot to take the to be continued off, but it's all good. I want to thank y'all for joining. Hope y'all learned a little bit today, and I hope you're excited for what is about to come. Having this in the game means that we are now able to start adding in a bunch of different things into the game. We can also start managing the player's movement through the dungeon without having to like manually update on each move. We're going to be building a really nice system here, and everything that'll play really nicely together, and it's going to be very easy to debug. So, until next time.